PT Pave is a dynamic venture between Amsteele Systems and Warehouse Construction, aimed at providing a complete package, one-stop shop for post-tension concrete pavements, also known as post-tension slabs of grade. Amsteele Systems' beginnings date back to the late 1960s, with CCL South Africa being the forerunner for amalgamated pre-stressing, who merged with Steeldale Systems in 2000 to form Amsteele Systems. Amsteele Systems have built up a reputation for excellence in the post-tensioning industry and are market leaders in this field in Southern Africa. Founded in 1993, Warehouse Construction has become known for delivering products and services of the highest quality. Identifying the niche of concrete flooring within the construction industry, Warehouse Construction SA has evolved as national leaders in this field since 1993. Warehouse Construction has achieved preferred supplier status among organisations such as Macro, Game, Builders Warehouse and the JD Group. Right now we are standing outside a 15,000 square metre warehouse, recently developed for M&T developments in Gauteng. We recently completed the internal floor, which took 27 working days from start to finish. Post-tensioning in concrete has two functions. Firstly, to counteract shrinkage cracking from 18 to 24 hours after placing of concrete, and then ongoing internal tensile stresses within the concrete, and that is due to environmental conditions, imposed loads, and also due to temperature gradients within the concrete. There's various ways of constructing an external pavement, otherwise known as a surface bed in South Africa. In this particular case, this is an unreinforced concrete surface bed or concrete pavement, and you can clearly see around me there is a joint pattern. And one of the reasons why you cut joints in a concrete slab is to prevent or to control the shrinkage cracking. And one of the biggest issues with this type of construction is the maintenance of the joint, which is a long-term issue. It costs the owner or the end user money. What we did on the inside of this warehouse, we did the entire 15,000 square meters with no movement joints, and that's what we're going to have a look at now. The total footprint of this building is 140 meters long by 100 meters wide. The objective when we started this project was to eliminate all movement joints inside the physical footprint of the building, so that all movement would actually happen right on the edges where there's no forklift traffic. This was achieved by stressing all adjacent pours together. The cables ran the full length of the building from edge to edge in this direction and also across the width of the building. Okay, what we're looking at here is just a diagram showing the actual footprint of the warehouse. The lines here, these are actually the construction joints, so I'll just say that's construction joint CJ. That's the center of the building in this direction. The center of the building in this direction is actually in the middle of this panel, so that'll be your center line of the building. Okay, and the way the sequencing worked, we started in the middle of the building, so this would have been 4-1, that'll be 4-2, 4-3, 4-4, 4-5. There were 14 pours in total, or 14 slab panels. The post-tensioning cables run right through from end to end. I'll show that in red color, terminating in what we call a pour strip around the perimeter, which is what you can see there. There's a pour strip all the way around the perimeter, and this happened in both directions. So this would have been your cables running through, terminating there and there. Right, so we started the first slab panel. The first panel is in this direction. Or over there you have the cables that run through. You have an anchor there and an anchor there. You stress this panel. When you do the panel adjacent to it, the cable obviously runs all the way through, and when you stress this cable in this position, it actually pulls this slab panel up against this one. So this construction joint is actually pulled up against each other. When you get to the perimeter, your pour strip, you need that there, that's 1 meter wide. The final stress is done inside this pour strip. This pour strip is conventionally reinforced, so and that gets filled in or concreted in once you've actually completed all the stressing around the full perimeter of the building. And that is how we actually achieved no movement joints within this entire 15,000 square meters or 14,000 square meters. Some of the more common applications or typical applications for post-tensioning in concrete pavements, this is both for external and internal use, is in things like distribution centers, warehouses like the one that we're standing in now, bulk storage facilities, aircraft hangars, raft slabs, all sorts of applications like that. Some of the construction benefits realized with post-tensioning in pavements include things like large joint-free areas like the one behind me, reduced construction cost, reduced subgrade preparation below the slab, an increased load capacity, and then reduced permeability.